Today we'll be covering 10.1 trigonometric functions of angles. Okay, this is part 1 of 3 parts. The very first thing that we need to know when we're learning about trigonometry is about radian measure. So for example, in Singapore, we measure length in cm, okay, and meters, okay. In some other countries, for example, in the US, they will measure length, which is still length, okay, but they measure it using inches. Similarly, okay, for angles, what we are commonly used to is the measurement in degrees, okay, but there's another unit of measurement that you actually learn in E-maths, that is the radian measure itself. So in a nutshell, what is radian measure? So if you look over here at this portion of the this page, okay, the conversions as such, pi radians, okay, so I'll write down here, pi radians, okay, pi radians is equals to 180 degrees, and it's all proportional. So for example, okay, what I have is, if I want pi over 2, so if I'm dividing by 2 on this side, I'll be dividing by 2 on the right hand side, so pi over 2 will actually give me 90 degrees. So now I'll write down for you here, pi over 4, okay, I'll write down another common one, pi over 3. I write down yet another common one, 2 pi, okay. You just take one moment, okay, think about it, pause the video itself. What are these 3 angles over here? When you're ready, unpause the video, I'll give you the answer. So if we always start with pi equals 180 degrees. So if I divide by 4, here, 180 degrees divided by 4, and if you have said it's 45 degrees, you're absolutely correct. Similarly, pi divided by 3, here I will also divide by 3. What I'll get here is 60 degrees. For 2 pi, if pi is 180 degrees, 2 pi itself will of course give me 360 degrees. There are of course other angles that are possible. So for example, what if we have 2 pi over 3 radians? What is it? Okay, so what we can do is we divide by 3 to get 60 degrees. Okay, so that's pi over 3 here. Pi over 3 is 60 degrees. We multiply by 2. 60 degrees multiplied by 2 is, of course, 120 degrees. So that, in a nutshell, is some simple conversion. And for this chapter, I think this simple conversion should suffice for the time being, okay, with regards to what the angles actually are. Okay, now, just a quick recap for something that we have actually learned in secondary 2 itself, okay, sine theta. So if you remember the acronym TOCASO, TOCA, and so, I think you're learning trigonometry already. So now, for example, sine theta, here's theta, is the opposite over a hypotenuse, given here. Cosine theta is adjacent over the hypotenuse, and tangent theta is the ratio of opposite over the adjacent. Okay, now, we can use a scientific calculator to find the trigo ratios of acute angles. So for example, what are some special angles? You need to know these trigo ratios. For example, if I ask you what is sine 30 degrees, straight away, or sine of pi over 6 in radians, sine of 30 degrees, immediately you must be able to tell me that, oh, sine of 30 degrees is equals to half. For example, if I ask you what is cosine of 45 degrees, so immediately you must be able to tell me that cosine of 45 degrees is actually square root 2 over 2. Similarly, if I ask you what is sine of 60 degrees, sine of 60 degrees is actually square root 3 over 2. Not to worry, okay, about these. It is true that you need to memorize these, but there's also a way, okay, where we can use our fingers to obtain these values. But let me show you how the derivation of these things actually go. Let's work with 45 degrees first. If I were to draw a square, okay, here is 1, here is 1. Okay, so for a square, I have a diagonal like this. So what I will form is an right angle isosceles triangle. This angle here will be 45 degrees. So if you draw this, you can actually start to derive sine, cosine, and tangent theta. For example, okay, in this case, sine of 45 degrees is opposite over hypotenuse. But wait, hey, I've not found what the hypotenuse value here is. So by Pythagoras theorem, 1 square plus 1 square square root, I will know that my hypotenuse value is square root 2 over is square root 2 itself. Hence, sine of 45 degrees opposite over hypotenuse is actually 1 over square root 2. If I multiply the numerator and denominator by root 2 over root 2, okay, we rationalize the denominator, the value that I'll get is square root 2 over 2. Similarly, cosine of 45 degrees, okay, is adjacent over hypotenuse. So what I get is 1 over square root 2. Similarly, it gives me square root 2 over 2. Tangent of 45 degrees is opposite over adjacent. So this ratio, tangent 45, is equals to 1. Now, the next thing that I need to find is for a equilateral triangle like this. If I have an equilateral triangle here, 60, 60, and 60 degrees, what I have here is a equilateral triangle. Then I divide the triangle exactly into two like this. Since it is an isosceles, an equilateral triangle is an isosceles triangle. If you drop the perpendicular down like this, what we will form here is a triangle like this, okay? And this angle here was 60 degrees. Hence, okay, if I divide the it's an isosceles triangle, so if I divide by 2, this angle here is equals to 30 degrees. This angle here being 60 degrees. Now we can start to derive the rest of these values. For example, sine of 60 degrees opposite over hypotenuse. But wait, I still need this value of m. So back when we had our equilateral triangle, this is 2, this is 2, this is 2. When you drop the perpendicular down, okay, it divides the base exactly into 2. It bisects the base. So this value here is 1. What we need to find is m. How to find m? By Pythagoras theorem, 2 square minus 1 square, we square root. So what we'll get here is 4 minus 1, this is square root 3. Hence, okay, what we will actually have here is this value of m here can actually be rewritten as square root of 3. Now we are good to go for 60 degrees. For example, sine of 60 degrees is opposite over hypotenuse is square root 3 over 2. Similarly, cosine of 60 degrees is adjacent over hypotenuse is half. Tangent of 60 degrees, tangent is opposite over adjacent, hence the value that I'll get here is square root of 3. Okay, take a moment now, alright? I suggest you take a moment, you pause the video itself, and then maybe you can try to fill in this side here for sine 30, cosine of 30 degrees, and tangent of 30 degrees based on this triangle and based on this 30 degrees itself. So now pause the video, go and give it a shot. Okay, when you're ready, unpause the video and I will actually give you the answers. Okay, sine of 30 degrees opposite over hypotenuse will give me half. Cosine of 30 degrees adjacent over hypotenuse will give me square root 3 over 2. And tangent of 30 degrees is opposite over adjacent is 1 over square root 3. If I rationalize the denominator by multiplying both the numerator and denominator by root 3, I'll get square root 3 over 3. Just like that. Okay? So once again, you need to be able to memorize these values, but again, not to worry, there's actually a way. Okay, so here what I have printed out is this hand. So what your teachers will actually go through with you in class itself is how to use the hand. Okay, then just remember that there is actually this square root symbol over your hand, and your wrist is the fraction 9 and is divided by 2. So this diagram over here will actually help you to actually figure out, right, what is the different special angles. Okay, now example 1. without using a calculator, evaluate this. So now, okay, based on what we have, if you had already memorized all of these values already, so cosine of 45 degrees, immediately you can tell me that is square root 2 over 2. Sine of 30 degrees itself, you can actually tell me that it's half. And tangent of 60 degrees will actually give me the value of square root 3. So you need to be able to see cosine 45 degrees and translate it to this. Similarly, sine 30 is translated to half, and tangent 60, you need to know the value is square root of 3. Then what we're going to do here is this. We will start to simplify this fraction. So square root 2 over 2 is 1 plus 2 root 3 over 2. So what I'll have is root 2 over 2 multiplied to 2 over 1 plus 2 root 3. So what I'll get is square root 2 over 1 plus 2 root 3. Now, to rationalize my denominator, just a quick recap of what we did in surds. You need to multiply by the conjugate of the denominator. So since the denominator is 1 plus 2 root 3, the conjugate is 1 minus 2 of square root 3. Then, if I continue to simplify, what I'll get is square root 2 minus 2 of square root 6 over a square minus b square 1 minus 12. So what I get is square root 2 minus 2 square root 6 over negative 11. Then if let's say you want to multiply both the numerator and denominator by negative 1, what you get is 2 square root 6 minus square root 2 over 11. Of course, if you want to leave it in this form, it's perfectly fine itself. Okay, for part B itself, okay, let me try to shrink this whole thing here. Okay, so for part B itself, what we have is tangent pi over 6, cosine pi over 4, minus sine pi over 3. What you need to know if you cannot what I call see this in your brain, if pi is 180 degrees, so what they're asking for here, tangent pi over 6 is, what we're looking for is tangent of 30 degrees, cosine of 45 degrees. 180 divided by 4 is 45 degrees. 180 divided by 3, okay, this pi is 180 degrees, is sine of 60 degrees. Hence, okay, for part B, tangent of 30 degrees, okay, so if you want to find the tangent of 30 degrees, you need to actually remember this. Tangent of 30 degrees will actually give me square root 3 over 3. Now, cosine of 45 degrees is square root 2 over 2 minus sine of 60 degrees. Sine of 60 degrees is square root 3 over 2. Okay, so tangent of 30 degrees will yield square root 3 over 3. Cosine of 45 degrees will give me square root 2 over 2, and sine of 60 degrees actually yields square root 3 over 2. So if I start, okay, to simplify, what I get is square root 3 over 3. Then inside my brackets, what I get is square root 2 minus square root 3 divided by 2. Then if I multiply, what I get is root 6 minus 3 over 6. And I am done with my example 1. Now, what I need you to do now is this, okay? This is try 1. So I suggest that once again, as you know my style, why don't you pause the video now and give try 1 a shot. And when you're ready, you can unpause the video and I will actually go through these questions. Okay, so tangent 45 degrees. Once again, tangent 45 is simple enough. Tangent 45 will actually give you 1. Cosine 60 degrees is half. and sine 60 degrees is root 3 over 2. Again, you need to memorize and know these what I call special trigonometric ratios. You just have to either memorize or your teachers actually teach you how to use your fingers to find this. So all that is left here is actually simplify the surd. So what we have here is you combine the fraction at the denominator. Then, okay, you take the reciprocal. So we get this step here, 2 over 1 minus root 3. Then, what we do here is to rationalize the denominator. We multiply by the conjugate of the denominator. 1 plus root 3, 1 plus root 3. Simplification here will yield 2 plus root 3 over negative 2. 2 divided by negative 2 yields negative 1. 2 over negative 2 is negative 1 times this square root 3. Hence, system here is negative of root 3. Now, the next thing here is this. What we're going to do here is this. Again, if you have not figured this out yet, okay, or you can't see it, you can actually use your pencil to write. Pi over 6 is actually 30 degrees. Pi over 3, is 60 degrees. Pi over 4 is 45 degrees. Hence, what you need to know is sine of 30 degrees will yield half. Tangent of 60 degrees is actually equals to square root of 3. And cosine of 45 degrees is 1 over root 2. Or, okay, actually I prefer cosine of 45 degrees. I actually prefer to memorize it as root 2 over 2. Okay. Now, what happens here is this. If I start to combine the fraction, I will try to do something slightly different from the answer suggested there. 2 minus root 3 over root 2 divided by 2. What I'm doing is just combining the, what I call two terms inside the brackets. Then I multiply the half in. So I get 2 root 3 minus root 2 over 4. I think it's a shorter method than what is suggested by the model answer there. Okay, example 2. Example 2 shows a diagram, triangle ABC, in which angle C is a right angle. Simple enough, okay. Angle APC is pi over 3 radians. Pi over 3, okay, now quickly, is how many degrees? It is 60 degrees, okay. P is the midpoint of BC. Alright, and then what we have is the length of AP is 10 cm. Without using a calculator, find the value of the integer k such that angle ABC is equals to inverse tangent of root k over 2. So basically it is this, okay, don't worry, it looks a bit fiddly. Inverse tangent of root k over 2 simply means that they want you to find tangent of angle ABC, okay, is equals to root k over 2. So as such, what they want you to find is what is tangent of angle ABC. So that's how I dissect this question. So tangent of angle ABC. If we look at this question here, okay, what we can do here is this. Where is ABC? So first and foremost, okay, ABC is simply over here. So we have pi over 3 here. So now, what we can actually start with is this. Why don't we use the sine of pi over 3? Okay, you may ask me, Mr. Sim, why straight away you know we have to use the value of sine itself, okay? So why I know that we can use sine itself is because I know the value of the hypotenuse, okay, and I want to find the length of PC here. Okay, so I want to find the length of AC over here, and AC is opposite over hypotenuse. So I can say is this. I start with sine of pi over 3 is equals to opposite over hypotenuse. Remember, pi over 3 is 60 degrees. Sine of 60 degrees is square root 3 over 2. So what I have is square root 3 over 2 is AC over 10. Multiplying both sides by 10, we get 5 of square root 3. So that is the value of AC. So why don't we just go ahead and we label 5 over square root 3. Similarly, we're going to need another length. and the length that we'll need is PC itself. So PC, in reference to this 60 degrees or pi over 3, this is adjacent, this is hypotenuse. Hence, what I can say is cosine of pi over 3 is adjacent over hypotenuse. Now, cosine of 60 degrees, 0, 35, 60, cosine 60 degrees, you should be able to write down that this value is equals to half equals to CP over 10. Hence, CP value is 10 times half, it is 5 cm. Okay, I'm just going to go ahead and highlight this. Okay, so I know the value of AC, I know the value of CP. So why don't I just go ahead and say that this is 5 cm. Since P is the midpoint of BC, so if PC is 5 cm, it means that BP is also equals to 5 cm. Wow, I have done so many of this already. There is a reason for all of this. Okay, basically now what I will actually need to find, okay, is the value of tangent ABC. Then don't itchy finger. Okay, do I need this hypotenuse AB? I don't need. Okay, because tangent of ABC is opposite over adjacent. So don't go and use Pythagoras theorem, go and find AB. Don't do needless things, okay? I have enough information for me to complete my question. So what I have is tangent of angle ABC is opposite, okay, is AC over BC. So AC is 5 root 3 and BC is 10. So what I get is this tangent of angle ABC. So tangent of angle ABC is equals to root 3 over 2. Now, if you remember, okay, in earlier in the question, we're trying to find this root k over 2. So simply put, the value of k is equals to 3. If you compare root k over 2, root 3 over 2, very clearly the value of k is equals to 3. So therefore, k value is equals to 3.